question about your motility plate assays. So anyone who's done motility plate assays with low auger knows that there's a large amount of variability between, and that you can get very different results if even there are slight changes in temperature, or if there are slight differences between the specific environments that the motility assays are performed at. Did you do the same assay where you had cells in the light and in the dark with wild type cells without your construct? Because that would be an essential control to show if the amount of swimming is the same between those two.
So wild type cells? Yeah.
Wild type cells without your construct.
Yeah, of course. Actually, the thing over here, those are transformed, but we have also, performed experiment using transformed cells.
I didn't see the data on your wiki.
Yeah, because that was really preliminary before this experiment. We have run a few experiments using the more or less the same setup, but we have allocated another control colony, which is the wild type E. coli.
So you have wild type E. coli in these experiments?
Not in this one that we showed, but we have done it previously, and we observed that it doesn't work, and we move on to this future experiment.
That data would be really important.
Okay.
To follow up on that, then, how would you control or separate the heat from the light component of your experimental design?
We separate the heat from using a transparent container with water. So light have to be passed through the water before going to the plate. So most of the heat are blocked.
Is absorbed by the water. Okay.
So you tested DH5 alpha, top 10 of BL21 for downstream application. I didn't see in your wiki like an explanation for why DH5 alpha didn't work.
Okay, there are several reasons. By comparing Rosetta 2 and DH5 alpha, Rosetta 2 has certain rare codon compensation in the system, and our fusion protein X actually originated from Archaea, which utilized several rare codon in E. coli. So for Rosetta 2, it certainly can express the protein better than DH5 alpha. And for BL21, most of us know that for BL21 there are several proteases being knocked out in the strain. So non-native protein can express better because they're not cleaved by the proteins. And for top 10, it has a plasmid keeping system so that more copies of the plasmid can keep in top 10. So with higher number of plasmid DNA, the translation will be more so that it can express the protein better.
So my question is, are your biobricks constructed and assembled in the biobricks standardization or not? Yeah, are your biobricks in the biobricks standard?
Basically, yes. We have put the construct into our PSP1C3, but we have added several research enzymes in it. So not 100% PSP1C3, but yes, it basically is the backbone.
Okay, but I have found some restriction and some size in your so it says that's not compatible.
Yeah, that which I had mentioned before, we have added restriction site before and after the central toxin gene. That's for switching the central toxin portion. Because there's additional information. Because according to some previous studies, actually there are many forms of central toxin mutated form which are made by other scientists, and they can, they're sensitive to wide spectrum of light source, so we can switch the portion. We can utilize light source more efficiently.
So my question would be, light will only penetrate so far into a relatively even dilute concentration of cells. What situations would you want to use light as a signal as opposed to small molecules?
Because light sources are cheaper for small molecules, like for chemotaxis like glucose or aspartate. Those are expensive chemicals. If you want to control cellular movement using chemicals, it will be more costly.
Well, when would you want to control cell movement?
When will we like to control cellular movement? That's a good question. Actually, cellular movement can be controlled or be used under circumstances like in previous IGEM team, they have designed construct to absorb heavy metal ions, or like last year's CHK IGEM team to absorb chloride ion. So for phototactic construct, it can be used for collection of cells in a specific region by only the light source. So heavy metal ions or chloride ions can be, collected and recycled.
Are there any more questions from the audience? No? Any more questions from the judges? All right, thank you very much.